Hello, Watauga Rising Engineers. In today's video, I want to go over a detailed review of the simple alarm system project. Now, the good thing about a video like this, it is maybe a little longer than the others, is that you can stop it, pause it at any time. If some of the stuff that we're going to be going over you've seen before, you can skip ahead. Or if it seems like we're going a little too fast for you, you can slow down, go back and review things. So please take the time to do that if you need to. The other thing is that I'm going to assume that you have been working on the project, or at least you've seen the demonstration video on how the alarm system works, how it functions. And I've also posted the solution code to the Google Drive, so all that's available to you. The purpose of this is to make sure we go over all the details of the project so that we understand everything, we're all on the same page. So let's get started with that. If you recall, we talked about this thing called a flowchart. Now what the flowchart does is it gives you a way of mapping out, figuring out how your code is going to look as you build it. So you don't have to kind of build it piece by piece without having a bigger picture. So this gives us a big picture, kind of like a picture of a puzzle that we can use to put the puzzle pieces together. Okay, and so it's always a good idea to do this first with any kind of especially large project you might be doing like this. And so if you recall, if we look up here on the left, all we're going to do with the alarm system is we're going to start off with, when you turn it on, it's going to be disarmed. So in other words, the motion sensor is not active, it's not looking for motion, it's not going to go off. It's waiting for somebody to come and push the arm button. And when they press the arm button, of course, there'll be a 20-second delay to give the user time to leave the room so that they don't set off the alarm by accident, that kind of thing. But if you look at the flow chart, what it's doing is it's checking the arm button, and then it's asking a question, did somebody press the arm button? Is it armed? If not, the Arduino loops infinitely. So this is our major loop. This is our main part of the loop right here. Okay, and then everything to the right of this diamond is going to be within our loop procedure, within the two curly brackets of our void loop. Okay, and so the Arduino will loop forever until somebody presses the alarm button. Hopefully somebody does. The arm button. Hopefully somebody does at some point. There'll be that 20-second delay in which we'll be flashing the LED once every second. And every second, what we'll also do is check to see if somebody has pressed the reset button. Okay, so somebody may have armed it and then decided, I don't want to arm it. They just hit reset. And if they do, then that'll just restart the Arduino back to its original state. But if nobody presses the reset button, then the Arduino will now activate the motion sensor and check to see if the motion sensor is detecting motion, and it'll just do that over and over again. If motion is detected, there'll be a 10-second delay in which the status LED will flash rapidly. Now it'll flash once every 1/5 of a second, 0.2 seconds. So it's going to flash 5 times a second. So that means it'll flash 50 times. We need to set up a loop for it to do that. And once it's done flashing, then it'll set off the alarm. It'll set off the lights that'll flash on and off once every second, and it'll do that for 20 seconds. And the other thing we're going to do is we're going to sound the alarm, changing the tone like a siren, like a European siren, once every second. We're only going to do that for the first 10 seconds. So the lights and sound will go off for the first 10 seconds, and for the second 10 seconds, only the lights will flash. Now, during both of these loops in which we're setting off the LED, the status LED, and setting off the actual alarm itself, we're going to be checking that reset button to see if anybody has come along and pressed it. Okay? And if they do, then of course we'll restart the system. So that's our flow chart. And we're pretty much, for the most part, going to be doing this. Okay. So, just recall, this is what the circuit looks like. We have on the right, this right-hand button right here that has this current limiting resistor to the button. The green is tied to ground, the red is tied to 5 volts, and those are our power rails here on our breadboard. This current limiting resistor limits the flow of energy from power to ground when somebody's pressing the button so it doesn't blow out the Arduino. And then this blue line here will detect a change in the switch, and that's tied to pin 3. So our ARM button in this particular design is tied to pin 3, and it is an input. Okay, and that's I just kept track of it up here on the left. The reset button here, the reset button on the left is our well, that's our reset button. It's tied to pin 4 up here, this blue line tied to pin 4. Our motion sensor is going to be sensing motion. It's tied to pin 2. It's an input as well. And then we have our outputs. We have our status LED, which is nice to have. It tells us the state of the system. So, you know, being the user of the alarm system, you want something to tell you what's going on, what state it's in, whether it's armed or not, that kind of thing. Of course, we'll have our speaker as an output. And recall that and that's tied to pin 5. Our speaker is just driven directly by the Arduino, and the other side of the speaker is tied to ground. You can use any speaker you want. You can use a speaker of a stereo system. There's 2 little wires that come out of the speaker. You can plug them right into the Arduino to ground. And then 7 and 8 are our LEDs, and those are the 2 circuits over here on the right, again with current limiting resistors. Here's our status LED on the far left. Now the 2 alarm lights over here, we have you doing LEDs, but if you look at the demonstration, we're actually using light bulbs that require AC voltage out of the wall socket. That's dangerous voltage. We're not going to be dealing with that here. But what we can do is use something called a relay, which is an automatic electromechanical switch that'll turn the lights on and off for us, just like a light switch on a wall, right? And the way you drive that, instead of using your finger, you just send a signal just like you would be turning on an LED. So effectively, it's like your code is going to be written exactly the same if you're driving LEDs or you're driving lights. The only thing that'll change is that we'll, instead of connecting it to an LED, we'll be connecting these 2 wires to relays. And that comes later. Okay, so remember this flow chart, and what we're going to do is to go from the flow chart to the code can be kind of tricky sometimes. And so one good way of doing that is to do something, write something called pseudocode. And pseudocode is a bridge between a flow chart or a state diagram and the actual program that you're going to write, the sketch that you're going to write for your Arduino. And so on the right here is our pseudocode, and it doesn't have all the details in it that the flow chart or the state diagram does, but that's okay. We know to fill those in as we go. So when you power up the alarm system, the void setup routine is going to set up the system. It's going to define our pin modes and initialize our variables, and it's going to initially disarm the system. And then we're going to loop forever, and at the beginning of the loop we're going to ask the question, is the system armed or not armed? If it's not armed, then we're going to go check the arm button. Was it pressed? Yes. If so, then you arm the system, okay? And you loop back up around and start the loop over again. Now that you've armed the system, whenever the program asks, is the system armed, you answer yes. And in that case, it's going to move forward down here and it's going to check the motion sensor. Is there motion? Was motion detected? Yes. Then set off the alarm and reset. If not, do nothing and just loop back up around. Okay? When you loop back up around, is the system armed? Well, yeah, it was armed earlier in the previous loop, so it's still armed. And it knows to now check the motion sensor again. Okay, if the motion, again, the sensor didn't pick up anything, it just keeps looping. Of course, the system's still armed, it's checking the sensor, and it loops forever and ever until motion is detected, in which case it'll set off the alarm. Okay, now up here, if the system is armed and the answer to that is no, then it'll be checking the arm button, and if it's not pressed, you don't do anything. You just keep checking to see if somebody presses the arm button over and over again until it's pressed. When it's pressed, then you arm the system, and the next time through the loop, the answer to that question, is the system armed, is yes. and you move on now to check the motion sensor. Now the delays and the light blinking and stuff like that, and the sound going off, I didn't put that arm. I put that in here. I just said set off the alarm. And we know what to do to set off the alarm. We've done that in previous projects. We've lit LEDs and we've sent sound to the speakers. So I'll neglect the details of that here. But we'll need to put that in our code. Now I'm going to present the code to you, and just to recall the format of our sketch, which is what the programs for Arduino are called. Any include statements at the beginning we need to put at the very top, and that's these hashtag include, okay, and that tells Arduino, wait a minute, go out and grab code from another file and bring it in and use it, okay? And we're going to use pitches.h. If you guys recall, pitches.h is called a header file. That's why it's called .h. Pitches.h is the header file that contains a library of variables assigned to different notes on a piano key. And there's a lot of lines of code in that include file. So it's kind of nice to use it as an include so that we don't have to type all that in every time we want to make a sound in some kind of program or sketch sometime. We just have to include it, okay? And so, in general, use include statements in header files whenever you want to include code that you're going to be using in other programs later, or other people might be using in their projects. Okay, in the void setup routine, inside the bracket of void setup, you're defining constants and variables, and you're initializing those values, okay? And of course, that's where you're going to be setting the pin modes. So the input or output state of each pin will be defined there, if you recall. And then in the void loop is the main program that loops infinitely, and that's where your code is going to go. At the very end, you're going to include subroutines that you might want to call in your project. In this case, we will be using a couple of subroutines, and so you'll want to put those at the end of your code. Now, if you haven't seen the video on subroutines or on variables, you should look at the other videos that are posted up to this date, up to this point, so that you don't get too lost in what we're going to be talking about going forward. Okay, so here is the sketch outline. Of course, the very first thing we do, as I mentioned, is we do include pitches.h, okay? And then we define our constants. In this case, I'm doing a constant, meaning it's not going to change its value throughout the whole program. It's going to be an integer, and I'm going to call this variable button arm, which is, you can call it anything you want. It's just a variable name, a constant name. And what I'm doing is I'm saying that pin 3, remember in the go back if you want to and look at the diagram, pin 3 is where we had our arm button attached to. Okay, so when somebody presses the arm button, that's actually tied into pin 3. And so I use this variable name here to tell myself when I see it later that it's a button, represents a button. Which button is it? It's the arm button, not the reset button. So I called it button arm, and it's assigned to pin 3 that corresponds to the circuit. And now I didn't include all of the constants here. I'll show you those later when I show you the full sketch, but they're all there, you know. So I'll have button reset. I'll also define the motion sensor pin and the LED pins and all that, okay? And then I have these other non-constants or variables. If it's not constant, that means it's allowed to vary its value. In this case, it's an integer, and this is button arm state. Now what this does is, remember when we do a digital read later on, what we're going to do is we're going to read in the state of pin 3 or button arm, okay? And when we read in that value, we need to store it somewhere so that we can look at it or change it or do stuff based on that value. And so button arm state is like a little placeholder. It's a variable that we can store the value that we read in using our digital read command. Okay? And so I didn't put all of those variable names in there. There's several. But again, when you look at the full sketch, you can see all the ones in there corresponding to this code. And when I initialize it to 0, that just says at the very beginning of the program, let's assume that the button is not being pressed. So it's in a low energy state. 0 corresponds to low. 1 corresponds to high. Okay? And then finally down here is a Boolean variable. Now there's also a video, I believe I posted a video on Boolean variables. If not, it will be coming shortly. But basically a Boolean variable is a real useful type of variable. And it only contains two possible values, either true or false. So in this case, I defined a variable called armed, and I'm going to initialize its Boolean value to be false. Okay, in other words, initially the system is not armed. So armed is false. If the system were armed, armed would be true. Okay, that's how I'm going to use it. And then of course we do our void setup routine in our program. This is executed only once by the Arduino, and this is where we do all of our pin modes. So remember, for example, here button arm is assigned to pin 3, and I need to define that as an input or an output. In this case, pin 3 will be an input because I read in information about whether somebody's pressing the arm button or not. The status LED would be a pin mode of output because I'm not reading anything in from the LED, I'm putting information to the LED, out to the LED. I'm either turning it on or I'm turning it off. I'm controlling it, right? So it's an output. Outputs are things that I control in my program. Inputs are things that control my program, that tell me what to do as I code things along. Okay, now what I'm going to do is present to you the entirety of the code, and I'm going to do it in a very sequential, logical way. On the left-hand side of the screen, I'm going to just make statements that make sense, logic statements, corresponding to our pseudocode and to our flowchart. On the right will be the actual code corresponding to those logical statements, so that hopefully the code will make sense to you this way. Okay, so let's get started. We're going to loop forever. Turn on the Arduino and there it goes. It's going to loop forever. And so that's what our void loop does, of course. And we have an open bracket for our void loop. And at the very end of the program, I need to close that bracket. Okay, so just recall that whenever I have an open bracket, I need a corresponding closing bracket. Otherwise, I'll get an error. All right, and so the two brackets work together to encapsulate or enclose code that is going to be done in a certain module. Okay, so in my loop, I need an open bracket and a closed bracket, which I'm not showing on this particular screen. I just didn't have room here. Okay. Okay, now let's get started. So the first thing I want to ask is the system not armed? All right. Now you may ask me, why don't you just ask the question, is the system armed, instead of is the system not armed? Well, there's a reason for that. Remember that we start off the program by initializing armed to be false. We said armed is false. The system is not armed. Okay? And so the reason that I'm doing it that way is I'm using this if statement here. Now remember, the if statement says that anything in between these two parentheses, not brackets, but parentheses, anything in between those two parentheses, if that statement in the parenthesis is true, then do everything between the following brackets. So if the stuff there highlighted is true, then execute everything in that bracket. Else, execute stuff in the following bracket. Okay? So if this statement is true, then do everything here. So if armed is false, then not armed is true. Okay? That's what that exclamation point there means. It doesn't have to be red. I just made it red in this case to emphasize the fact that it's there. It's kind of easy to miss. But by putting an exclamation point out in front of a Boolean variable like that, you're inverting it. You're taking something that's false and making it true, or something that's true and making it false. Okay? So what I'm saying here is if the system is not armed, then do everything in the bracket. Now remember, armed is false. So not armed is true. Armed is false. So not armed is true. Thus, do everything in the brackets. Okay? It's a little tricky, but that's the way these things work in programming. It's logic. Okay? So the next thing we do is if it's not armed, if that statement is true, then we need to go check to see if somebody pressed the button. So this is, we're going to go check the button arm, And remember, we're going to store the state of the arm button into that variable button arm state. We need to do our digital read, and we're going to go read on pin 3, which is I called button arm. Okay? And digital read is always highlighted in orange because that is an Arduino. It's kind of like a subroutine. Okay, it's a special Arduino command. You're telling the Arduino to do all this stuff that you don't have to worry about. It's going to go read information from the pin. So digital read is actually a subroutine with a lot of lines of code in it that you don't have to worry about. It's just a subroutine that we're using. So it's going to go read the state of that pin for us and store it into that variable. Okay. Now, was the button pressed? In other words, was the state of the button, the arm button, high? Did somebody push it? Then if that statement is true, then execute everything in this bracket. So notice how I added a bracket here. When you ever have an open bracket, you need a corresponding closed bracket. Okay, so we went from no bracket at the bottom, no bracket at the top here in this area. And whenever I add an opening bracket, I'm going to add a corresponding closed bracket and then fill in the stuff in between. Okay, so anyway, if my button arm state is high, then go do this stuff in here. What are we going to do? Well, the first thing we need to do is we need to keep track of the fact that our system is now armed. Now, this statement, armed equals true, doesn't control anything on the Arduino itself. What it does is it controls our program. Because later, when I loop back up around and I ask the question if the system is not armed, then that gray command right there, that gray statement right there is going to be false, right? So, in other words, I've gotten to this point where somebody's pressed the button and now my system is armed. Remember, it's going to eventually loop back up. And I don't want to go through all this code again if my system is already armed, okay? So that's why I make armed equals true, so that when the Arduino sees that if statement again, it knows it's false and it won't do all this stuff again. No need to do it again, because I'm going to flash my status LED 10 times, and I'm going to check the reset button. Okay, so let's go back here. My system is now armed. I need to tell the user I need to flash the status LED once per second for 10 seconds. And so to do that, I use my for statement. Okay, I'm going to blink the status LED 20 times once per second. And so remember, the for statement says, this is our control for our for statement. It's just going to loop. It's going to loop this bracket right here, in this case 20 times. And so we use this index. If you recall, we talked about indices in for loops. I is an integer, and it's going to start with a value of 1. And every time it loops, it's going to increment it by 1. That's what the plus plus I equals. Now, that's what that means. And so it'll loop through this until I is greater than 20. So as long as it's less than or equal to 20, it's going to execute the stuff in this loop. In this case, I'm going to do a digital write to my status LED. I'm going to turn it on, wait half a second, turn it off. So that occupies a full second. On, off is 1 second. Now, when I turn it on and off, I do need to check to see if somebody made a mistake and they need to hit the reset button. So I'm going to go read the state of the reset button, and if the reset button was pressed, then I want to restart the system by calling a subroutine that I'll show you later called restart. Okay? All right, now you can see I put little comments here. The // means that the Arduino will ignore all the stuff out there. It's just information for you to keep track of when you go back and look at your program. So this just keeps track of the fact that that closed loop closes this for loop here. This closed bracket closes this opening bracket here, and then this closed bracket closes my if not armed bracket up there. Okay, and so if it wasn't armed, it's going to do all this stuff. Now, for the sake of brevity, I need to stop, because otherwise I believe that YouTube will not allow me to post this. I will pick up part 2 here in just a moment. All right, I'll see you in just a minute.